Hello there and welcome to Lower 6th Further Maths A-Level Pure Core 1 past paper June 2013, and it's one of these favourite ones of mine, proof by induction, and it's a matrix one. So let's first of all leave us lots of space. We're looking to prove for all n existing in the positive integers that 3 minus 4, 1 minus 1 to the power of n can be represented as this matrix here. So as is the same starting place for all proof by induction questions, we are going to prove that this theorem is true for n equals 1. So when n equals 1, 3 minus 4, 1 minus 1 to the power of 1 is 3 minus 4, 1 minus 1. Nicely and easy to start with. The next one is going to be 2 lots of 1 plus 1, 1 minus 4 lots of 1, 1 minus 2 lots of 1 is equal to 3 minus 4, 1 minus 1. Great, so we have here left hand side equals right hand side for n equals 1, which is just what we want. The next part is to assume true for n equals k. So we're going to assume that 3 minus 4, 1 minus 1 to the power of k is equal to 2k plus 1 minus 4k, k, and 1 minus 2k. Right, okay, so now's the challenging bit. Now's when we need to prove true for n equals k plus 1. So what we want to show here is that 3 minus 4, 1 minus 1 to the power of k plus 1 is equal to 2 bracket k plus 1 plus 1 minus 4k plus 1, k plus 1, and 1 minus 2k plus 1. So that's what we're going to want to show. This is our target. So we'll start with the right hand side and work our way over to the right hand side. So left hand side equals 3 minus 4, 1 minus 1 to the power of k plus 1. Now let's expand this and treat it as our matrix times by to the power of k, and split up the indice and multiply it by the matrix again. Now the reason we're doing this is so that then this part here we can use our assumption. So this is going to therefore equal 3 minus 4, 1 minus 1 to the power of k is the same as our assumption matrix, 2k plus 1 minus 4k, k, and 1 minus 2k, and then times it by our matrix, 3 minus 4, 1 minus 1. Okay, so let's go ahead and do this. 3k plus 1 times 3, 2k plus 1 times 3 is 6k plus 3. Moving across and down, take away 4k. So that's the top left cell. 2k plus 1 times minus 4, so that would be minus 8k minus 4. Moving across and down, that would be plus 4k. 3 times k, moving across and down, we'll add 1 minus 2k. And for the last cell, it's going to be minus 4k, take away 1, add 2k. So let's simplify all of our terms that we've got here. 6k take away 4k is 2k plus 3. We have minus 4k minus 4. 3k minus k is k plus 1. And the last cell is going to be minus 2k minus 1. Right, okay, so let's see how close we are to our want to show in our right hand side. So The top left hand cell, 2k plus 2 plus 1. Yeah, that's exactly what we've got here. I'll just have to rewrite that as 2 bracket k plus 1 plus 1. But those two expressions are equal. Minus 4 bracket k plus 1. Yeah, that's exactly what I've got there. So I'll just write that in as those two expressions are equal. K plus 1, yeah, that's nice and easy. That's just still k plus 1. And I just have to double check it. Minus 2k minus 1, that'll be minus 2k minus 2, but 1 minus 2 is minus 1. Yeah, that's great. So that's exactly what I have in the bottom right hand part of my cell. And that's exactly what I want. That is exactly the right hand side of my equation. So I've completed part 3. Part 4 is in the answers in the mark scheme. I'm not going to write that down. But what you want to write down for part 4 is your conclusion, and it will basically say, given that we have shown true for n equals 1, assuming true for n equals k, we have proved our theorem true for n equals k plus 1. Therefore, by mathematical induction, for all values of n existing in the positive integers, that's really important, n existing in the positive integers, and then rewrite out your theorem. 3 minus 1, 1 minus 1 to the power of n equals 2n plus 1 minus 4n, n 1 minus 2n. And there you are, 5 marks.